Hello, hello students. Yes, still some people are coming. Okay, I will wait for 2 minutes now and join quickly. It is delayed by 15 minutes. Okay, today's I will be teaching you atoms chapter. Okay, a nuclei chapter will be in the next session. I will be taking that today or tomorrow. Tomorrow I will be taking. Okay. But today, now we are going to discuss the atoms completely. Okay, with all type of questions that are asked in the Neet papers, we will be discussing. Yes, I will be waiting next 1 minute. Yes. Then let's start the chapter. Welcome to Neet City Mentors. Today's the awaited chapter is atoms. I will be solving the total nearly 15 questions, okay, which are from the different concepts. It includes all the different concepts and which will be surely comes in your NEET exams exactly or the same models and the same concepts. And without delaying, let's start the first question. Yeah. Which of the following is true? First one. Lyman series is a continuous spectrum. And second option. Bastian series is a line spectrum in the infrared. Third option. Balmer series is a line spectrum in the ultraviolet. And the fourth option. The spectrum series formula can be derived from the Rutherford model of the hydrogen atoms. See here, analyze the first option. Lyman series is a continuous spectrum. Where does the Lyman spectrum comes under? Lyman spectrum, see here, these are Lyman series not under the continuous spectrum, and the second option, Bastian series is a line spectrum in the infrared. Yes, see, I will be explaining now. You all know those Lyman, Balmer, Bastian, bracket, and Funds, right? Lyman, Bastian, bracket, Lyman, Balmer, Bastian, bracket, and Fund series. The Lyman series is in the ultraviolet rays, is in the range of ultraviolet rays, whereas Balmer series comes under the visible rays. Okay, and next all the three comes now, that is Bastian and bracket and Fund series, which will comes under the infrared rays. So the Bastian series is the line spectrum in the infrared rays, which will be the correct answer. Whereas the first question is a continuous spectrum they have given. No, it's in the line spectrum. Lyman series lies in the line spectrum. Here see Balmer series, which is given in the ultraviolet. No, ultraviolet. Where does Balmer series comes under? Which will comes under the visible rays. Okay. It can't be, spectral series can't be derived from the Rutherford's model of hydrogen. Okay, this is a wrong one. So our as of question, which is a true, means the second option, that is Bastian series lies in the spectrum in the infrared rays. Okay, once again resolve it. I will be giving 20 seconds. Revise it. Yes, coming to the next question. Yes. Yes. The second question. The energy required to knock out electron in the third orbit of the hydrogen atom is equal to. The energy required to knock out the electron from the third orbit of the hydrogen atom is equal to. Okay. Understand the question? How much energy is required to remove the electron from the third orbit of the hydrogen? What is the value of that they are asking, you know? The options are as same in that fashion. You know one formula, that is the electron or energy, how much energy means the energy required to remove the electron. There is a one formula, that is energy required to remove the electron is energy is given by, that is, you know, we are talking of the, you know, positive energy, that is how much energy is required means which will denotes the positive sign. Okay, so 13.6 divided by n square electron volt, this is the energy required, whereas energy of the electron, if you say, means that will be in the minus sign, 13.6 by n square electron volt, but you require something energy to remove means which will be in the positive sign. Again, you know, n means the orbit, it denotes the orbit where it lies. From this formula, from the question what we they are asked means to remove from the third orbit. So minus 13.6 by n square means third orbit means 3 square electron volt. Solving that, sorry, plus 13.6 by 9 electron volt. So 13.6 by 9 electron volt, which will be positive or negative. If at all the option here they are given positive, second option, if they are given a negative also, you would have been confusion, but you should choose the positive sign because they are asking about the required energy, not of the energy of the orbit, electron in the orbit. It is but they are asking the required to remove the electron, so which will be the positive sign. Okay. Yes. Revise it in 20 seconds. I'll be with the next question. Okay. Recall it once. In physics, what happens, you know, just reading the question is not a method. You have to visualize the question again. Only solving once is not enough. Once now I have solved the question. After that, what you have to do means take a 30 seconds and again recollect the information, how you got the answer, how you are getting that, what steps are involved in that. Then you will catch the questions, catch the concepts in the next time. Okay. Yes. Revise it. Yes. Moving on to the next question. An electron has a mass of 9.1 into 10 power minus 10 31 kg. It revolves around the nucleus in a circular orbit of a radius 0.529 into 10 power minus 10 meter at a speed of 2.2 into 10 power 6 meter per second. Okay. The magnitude of its linear momentum in this motion is, yes, they have given a mass. Okay, and they have given a mass, they have given a radius with the speed with which it is revolving, and they are asking of the linear momentum of this motion. Yes, what is the linear momentum? linear momentum. What is the formula of the linear momentum? Linear momentum is equal to, that is m into v. Okay, mass of the electron and velocity of it. So mass of the electron they have only given 9.1 into 10 power minus 31 kg, and velocity of the electron is given, that is 2.2 into 10 power minus 24 kg, 24 meter per second. Yes. After solving this, what answer we will be going to get? Just solve it. You know, in physics, it doesn't matter how you are getting the concept. During calculation also, calculations also matters a lot. 2.2 into 10 power 6. Okay, sorry. Yeah. You have to solve that equation. See, I will be telling you easy trick. Just take a power out once, that is minus 31 and 6, which will be 10 power minus 25. Okay, after that multiply these two. 22 1 ja 22, 22 9 ja 198. Okay, 190 means it will be 200. Okay, there is a 2 points. Okay, 20 into 10 power minus 25, which will be, which we can write it as a 2 into 10 power minus 24 kg meter per second. So the answer will be second option. This is what linear momentum. L is equal to m into v. P is equal to m into v. Sorry. If they are asking the angular momentum, means L is equal to, angular momentum is given by m into v into r. See, sometimes they will confuse by giving the extra data also. They have given the radius here, but they are asking the magnitude of linear momentum. So radius given here, it doesn't require for the linear momentum. If they are asking for the angular momentum, means we have to use the radius data also and do solve it. For you to solve this angular momentum, what is the value of angular momentum? Do solve it. Okay, it's a classwork for you. Yes. Moving on to the next question. Energy level of A, B, C of a certain atom corresponding to increasing value of energy, that is energy of A energy less than the energy of B less than the energy of C. Okay. If lambda 1, lambda 2, lambda 3 are the wavelength of the radiation corresponding to the transition from C to B, transition from C to B, transition from B to A and C to A respectively, which of the following statement is correct? Okay. In the radiation, the wavelength from the C to A and B to A and C to B are given. We have to find the which options will holds the good here. Yes, this type of questions will repeat in the Neet. Okay, Neet exams it will be repeating. How to solve this question? If you ask, means if you go through the tricks, then it will be easy, I guess. Okay. You know, the basic formula, that is lambda is equal to Hc by E. That is, if you doesn't going to take energy as here, then energy is equal to hc by lambda. Yes. Now calculate it. That is, which statement? That is for the lambda 3 here. If we are going to take a lambda in terms of the lambda 3 means, okay, the radiations here, first one lambda 1 will be coming from C to B, that is lambda 1. From B to A, the following radiation is a lambda 2. From C to A, directly C to A, it is of a lambda 3. So we can take into the lambda 3, then we will be getting the lambda 3 relation in terms of lambda 1 and lambda 2. So take it, 1 by lambda 3 is equal to 1 by lambda 1 plus 1 by lambda 2. Okay. Take LCM of the lambda 1 lambda 2. So lambda 1 plus lambda 2 divided by lambda 1 lambda 2, 1 by lambda 3 is equal to, but they have given a relation in terms of lambda 3, we have to inverse it. So lambda 3 is equal to lambda 1 lambda 2 by lambda 1 plus lambda 2. So this is the correct answer. I will be recapping this question. This there is a radiation from the different wavelength. From C to B, lambda 1 is falling. From B to A, lambda 2 is falling. From C to A, lambda 3 is falling. Their options are given in terms of the lambda 3 mainly. So just follow which will be correct. Lambda 3 is a total radiation from C to A. In that radiation, lambda 1 and lambda 2 are going to add, because you can't directly say lambda 3 is equal to lambda 1 plus lambda 2, because the energy is equal to hc by lambda is a basic formula. So lambda 1 by lambda 3 is equal to 1 by lambda 1 plus lambda 2. Take the LCM. After that, 1 by lambda 3 in terms, you will be getting lambda 1 plus lambda 2 by lambda 1 lambda 2. Then reverse it. So you will be getting lambda 3 is equal to lambda 1 plus lambda 1 lambda 2 by lambda 1 plus lambda 2. This is how you have to solve this type of question. Take 20 minutes and visualize this question. Yes, moving on to the next question. The ionization potential of the hydrogen atom is 13.6 electron volt. The energy required to remove an electron in the n is equal to 2 state of the hydrogen atom is, okay, they have given ionization potential of the hydrogen atom value. They are asking for the energy that is required to remove the electron in the n is equal to 2 state. Okay. The basic formula we have discussed before, that is energy required, we have discussed in the first question, where it is a positive sign, but they are asking the energy of the same type. This question we have solved. Okay, this type of question, same again, it is repeated. You solve this question. Okay, that is, I told you energy is equal to 13 point plus 13.6 by n square, where n is equal to 2. We have solved for 3, now it is for the 2 square, which will be 4, 13.6 by 4, which will be, after solving this, you will be getting the positive 3.4 electron volt. Same type of question I will be taking because to resolve again how you experience it. Okay, recap this question. Yes, moving on to the next question. Consider an electron in the nth orbit of the hydrogen atom in the Bohr model. The circumference of the orbit can be expressed in terms of de Broglie wavelength lambda of that electron as. They are telling electron in the nth orbit of the Bohr's model is there. They are asking about the circumference of the orbit. In terms of wavelength, they are asking. Okay. During the electron revolution, when electron revolve under the orbit, it will be having some angular momentum, and this angular momentum relation will be given by the Bohr's model, okay, Bohr's theory. So according to the Bohr's theory, angular momentum mvr is given by nh by 2 pi. nh by 2 pi. This is the theory that is given by the Bohr's, which will be for the angular momentum. And next, what they are asking? They are asking about the circumference of the orbit. The basics, that is circumference. How to find the circumference of the that orbit, orbit, that is 2 pi r. Circumference is 2 pi r. 2 pi is below and r is here. You can take this 2 pi into the left side. You will be getting 2 pi r is equal to nh by mv. Yes, nh by mv. See, again, what is the h by mv? That is n is equal to h by p means we can write this h by p as a lambda. The basic formula again, this mv is equal to, you can replace it by lambda is equal to h by mv. This is the basics we all know. So because options is in terms of the lambda and they are asking in terms of the lambda, you have to replace the h by mv by lambda. So finally n into lambda is the answer. I think you are understanding this, okay? Bohr's theory, angular momentum formula you should apply. After that, take this mv in h by mv in terms of lambda, then the circumference will be n lambda. Yes, moving on to the next question. Radius of the electron's second stationary orbit in Bohr's atom is r. Then radius of the third orbit will be, the basics, that is the radius is directly proportional to the square of the nth orbit. Radius of the stationary orbit is directly proportional to the square of the nth orbit. Okay, so now they are asking for they have given radius of the second orbit. So they are asking for the third orbit. So r3 divided by r2 is given, we can write it as inverse directly proportional relation is there. So R3 is we have to finding R3, but R2 they have given, that is R, and we have to find the this R3 relation now, right? So n square means what? This is R they have given, we have to find the, see this, if you consider R, this is the third radius they are asking. Radius is directly proportional to n square, n sorry, you see R3 by R2, where R for the R2, R3 is a n square, that is 3 square, which will be 9R by R, which will be 9 times, which will be meaning so is 9 times the R. They are asking in terms of the, so the option will be third one. The basics is radius is directly proportional to the n square. Let's move on to the next question. Yes, an electron jumps from fourth orbit to the second orbit of the hydrogen atom. Given Rydberg's constant, that is R is equal to 10 power 5 per centimeter, they are asking frequency in hertz of the emitted radiation will be. They are asking of the frequency per hertz. Yes. If they are asking for the frequency, means how to find this? See, you know the basic, that is 1 by de Broglie Rydberg's constant, that is 1 by lambda is equal to R into 1 by n1 square minus 1 by n2 square. Electron jumping from the fourth orbit to the second orbit. So n1 square here represents a final, okay, final orbit. It is the initial orbit. By substituting R is equal R into 1 by n1 square means 2 square minus initial means, which will be 4 square. So what is they are asking in terms of solve this, okay, is equal to R into 1 by 4 minus 1 by 16, which will be, that is 3 into 3R by 14, 3R by 16. Okay, this is what the 1 by lambda value. For the lambda value, which will be lambda is equal to 16 by 3. Okay, again see here what they are asking, they have given here R is as a 10 power 5 per centimeter. So substitute that lambda is equal to 16 into 10 power 5 by 3. So you are getting this value. They are asking, frequency they are asking, not this is the final. They are asking for the frequency of the emitted radiation. How to find this? The basics formula, that is a frequency n is equal to c by lambda. We have a lambda value that is 16 to 10 power of 5 divided by 3. Substitute this in this. See the speed of the light 3 into 10 power of 8 divided by lambda, that is 16 into 10 power of 5 divided by 3. So you will be getting this 3 will be goes up 9 by 16 and sorry, see, there are, in terms of they are given per centimeter, you have to do it, means you have to keep this 10 power of 5 below, because they have given in terms of minus 5, right? So is 10 power of minus 5, which will be going up now. Then 10 power 8 into 10 power of 5. They here are in terms of per centimeter given. It is not a centimeter, it is a per centimeter. So it will be having a positive, it will be in the denominator place. So if you go to the numerator, it will be positive. 10 power of 8 plus the 10 power of 5 will be 10 power of 13. So final value will be 9 by 16 into 10 power of 15. 10 power of, it will be 13, right? 13, not 15, 13. They have taken n as here. I think this option is wrong here. The n value is 3 into 10 power of 8 actual value, but now given as a 10 power of 10. So I think its option is wrong here. Yes, next question. The ionization energy of a 10 times ionized sodium atom is. They are asking the ionization energy of the 10 times sodium atom is. See, are you getting any clue here? That is hint here. They are asking 10 times ionized means they are they are talking about the hydrogen atom only. So they are talking about hydrogen atom. So you have to apply the hydrogen atom concept here. Energy ionized that of the sodium is equal to Z square times the ionized of the hydrogen atom, right? 10 times ionized means the 10 electrons are removed from the 11 sodium atom, that is n sodium having atomic number 11. 10 times ionized means 10 electrons are removed from that, so only one 10 protons are removed from that, only one proton left. That means it is of a type of a hydrogen atom. The basic formula, that is ionization energy is Z square times the hydrogen atom. That is what the atomic number of the sodium, 11 square. It will be 11 square into the energy of the hydrogen in the ground state is, that is 13.6 into electron volt. So the answer will be, after calculating this, we will be getting see, they have given directly, there is a fourth option, 11 square 13.6 electron volt. So that fourth is the right answer. Next, yes, next we will be going on to this concept. Okay, see here, students. If the wavelength of the first line of the Balmer series of the hydrogen is 6561 angstrom, then wavelength of the second line of the series should be. This question will be repeatedly asking in the Neet. Okay, they have given the wavelength of the first line of the Balmer series. They are asking for the second series. So how to tackle this? How, what's the formula will applying for this problem means? See, you know the basic spectral line formula, that is 1 by lambda is equal to r into 1 by n square minus 1 by n square. From this formula on, it will be solved. See, Lyman Balmer Paschen bracket funds, Balmer is lies in the second line. Okay, so 1 by lambda is equal to r into, you have to take n1 as a 2 because it's a Balmer series, 2 square minus, it will be going to what, third line series, right? So 1 by 3 square, which will be, you are getting as a 4 here, 9 here. After taking LCM, you will be getting uh, you will be getting what, 9 minus 4, it is 5 by 36 times r. This for the second line. Okay, next, to find out from the second to the fourth how it will be, whereas second series should be, so 1 by lambda is equal to, lambda 2 is equal to r into 1 by 2 square minus 1 by 4 square, which will be, solve this taking LCM, you will be getting 3r by 16. See, this is for the second one, second relation, this is for the first setting. They are asking for the uh, you know second one. So lambda 2 by lambda 1 is equal to 20 by 27, which is equal to, in terms of lambda 1 is equal to 20 by 27 into 6561. So calculating this, you will be getting 4860 angstrom. This type of questions will be asked in the exams. Okay, so this is how today's atoms chapter goes on. See, actually the atoms and nucleus chapter, some basic formulas are there, just basics they will ask, they are not going into deep. And these type of topics are sometimes boring, but you have to study for the need. Fixedly one question is compulsory from the atoms chapter. I will be discussing nuclei still better in the next session. Okay,
Okay, done.